And subtract polynomial expressions. So like a trinomial from another trinomial, a binomial from another binomial, and so far and so forth. So before we even learn how to do that, we need to figure out how we do these types of questions. So when we've talked about polynomials, we've talked about two things. We talked about a term, which consists of two parts. So the coefficient, which is just a number, and the variable part, which is just symbolized by a letter. So can someone give me an example of a term? What would a term be? Kareem? 2x. Someone give me another example. Matthew?
5y.
5y, and one more. Someone give me one more example. Claire? 6d? Yeah, sure. 6d. Now, these terms can make up a polynomial expression. So we learned about 3 polynomial expressions. Do you guys remember what they're called? This is good warm-up for tomorrow. Okay, so what's one of them? You said it. No, the one with the T. Trinomial, so that's one. Someone said binomial. Yeah, what's the last one? Monomial. So just think of mono. Okay. So someone give me an example of a trinomial. So remember, they have to be separated by addition and subtraction. Matthew.
5y plus 2x minus 7x.
Nope. Be careful. 7x and 2x have.
7c.
Sure. That's fine. So it's a group of terms. It's separated by addition and subtraction, and we have 3 different ones. What is a binomial? Someone give me an example. Maya. 4a plus 3b. Perfect. And someone give me an example of a monomial. It's one term. Someone give me an example. You guys already did it in the previous one. Yazin? 7x. Perfect. 7x. So remember, they're separated by addition and subtraction. So a trinomial has 3 terms. A binomial has 2 terms. And a monomial has 1 term. And anything that goes above the 3 terms is called just a polynomial or an n-term polynomial, so like a 5-term polynomial. So what if I gave you guys this? What would this be considered? What would this be considered? Matthew. Do you notice that some terms have something in common?
Like x or 2x.
Yep. So which ones have the same base?
3x or 2 and 2x.
Yep. So 3x squared and 2x squared, negative 2x squared, have the same base or the same variable. So realistically, what type of polynomial is this then? If those, you can break them down into one simple term. Kareem? No? Claire? It's a trinomial. The reason it's a trinomial is because, like I said, 3x squared and minus 2x squared, they share the variable part together. So both of them have x squared. And when you have 2 things or 2 terms that have the same variable, you can either make them bigger or smaller depending on the operation that it's going to take. And I'll explain that more in depth shortly. So, and this is where we get into the language of something called like terms. So 3x squared and negative 2x squared, they're also called like terms. They're like terms because they are alike and share one characteristic that is the same. Okay. So now let's go on to what a like term is. So a like term are terms that have identical variable parts. So like what we saw with 3x squared and minus 2x squared, the x squared was the same. So these are called like terms. So can someone give me an example of what a like term is? Give me a pair of like terms. Kareem.
5x. Sorry, 5x squared.
Okay, and what else?
2x squared.
Yep. So as you can see, my variable part is the same. Both share x squared, but the only difference they have is the coefficients in front of them, which is the 5 and the 2. Okay, so they share the same variable part, just their coefficients are different. Someone give me another example of a pair of like terms. Yes, Kareem.
So if it was like without the like squared and there were like 5x and 2x, would it still be like?
Yep. Yazin?
1x and 3x.
X and 3x, perfect, because they share the x part together and their coefficients are different. Sean, give me one last one.
5 and 7x.
Okay, 5x and 7x, that is also a correct example of a like term. Now, the easy part is, what are examples of things that are not like terms? Adam.
3x and 7y.
3x and 7y. As you can see here, the variable parts are different. I have an x here and I have a y here. So these are automatically called unlike terms. Yes, Adam?
If the coefficient was the same, would it be a like term?
Nope. It has to be the variable part has to be the same. You can have 2x and 2y, but because my variables are different, they're not like terms. And the reason being is because when I tell you what x is and I tell you what y is, they're not going to be the same number. I can say let x be 2 and let y be 3, right? They're going to be different values most of the time. And give me one more example of something that's not a like term, Austin.
A and 2b.
Yep, a and 2b. So as you can see here, a and b are different, so these are also unlike terms. So a polynomial is in its simplest form when there are no like terms left at all. So the example I did above with 3x squared plus 4x minus 2x squared plus 7, I'm going to write it down here. This is not in its simplest form. So it's not simplified. So can someone identify here what my like terms are? I'm going to move it up. 4x squared plus 3x minus 2x squared plus 7. What are my pair of like terms? Adam.
4x squared and 2x squared.
Negative 2x squared. Don't forget that important part. Does anyone know how they would add or subtract these? I'm going to take a guess. I've showed some of you this before, where you guys have said x plus x gives me x squared. Do I have to add the x squares, or does my variable stay the same? Laura? The variable has to stay the same, okay? Because if you guys do x squared minus x squared gives me like negative x4, it's not going to work. So you're always going to leave this guy the way it is. So x squared is going to be x squared. The only thing you're going to add or subtract are the coefficients in front of them. So what would 4x squared minus 2x squared give me? Remember, you're just subtracting the numbers in front. Alice. Yep, 2. That's 4 minus 2 gives me 2. So I got 2x squared plus 3x plus 7. Okay? And this, are there any more like terms, or is this as simple as it gets? It's as simple as it gets. So this is known as a trinomial. And whenever you guys have a polynomial expression, what do you notice about the degree or the exponent as it goes from left to right? Is it getting bigger or smaller? Anyone? Matthew?
Bigger?
Nope. Nope. Look at my exponent. 2, 1, and here I have no variable.
No.
Kareem,
Small.
getting smaller. So when you write polynomial expressions, you go from highest exponent to lowest.
So the coefficient, like, really, it matters, but like, it doesn't matter as much as the.
Yep. So now I'm going to give you guys one more example to see if this sticks. So I have 8x cubed plus 2x4 minus 3x cubed plus 2x squared plus x minus 1. Seems like a lot of terms.
Yes,
What you're going to do first is you have to identify the like terms that you have in this expression. So what are my pair of like terms here? Sean?
8x
Mhm.
to the power of 3.
Yep.
2x to the power of 4.
Nope, that's not like it has a 4.
Oh, sorry, negative 3x to the power of 3.
Yep, and that's it. Because everything else has an exponent of 4, 2, and 1. So who can tell me what 8x cubed minus 3x cubed gives me? Kareem?
5 x to the power of 3.
Yep. Plus 2x4. Everything else remains the same because they don't have like terms.
So then is the problem solved there, or is it like?
The problem is solved here, but how do we write my polynomial expression? We said it goes from highest exponent to lowest exponent. Yes, Kareem?
Would you put them in order, like it would be 2 to x to the
Yep.
power of 4, 5.
Yep. There we go. Good. You're on a roll today, man.
Also, we carry the variable in the exponent.
Yep. The reason you carry them is because they're stuck together by multiplication. You can't really separate them. Visual learner, right?
Really?
Now I have a question. So I'm going to keep this here. And I have a question in this box over here. So are 2x to the 4 and 3x squared to the power of 2, are they like terms? You can practice your exponent laws right now. Danica? Yes? Can you tell me why? Think about your exponent laws. What law am I using here? When you have an exponent inside the bracket and then outside the bracket. Let's see. Do you remember or no? Joey?
Adding.
Close. Adding only happens when we're multiplying with the same base, right? We have an exponent and an exponent. What do I do with two exponents together? Danica? Okay. Maya? It's the power to a power. Okay? So the answer is yes. Okay? So if I were to simplify 3x squared to the power of 2, where does my exponent 2 go into as well? Remember, 3 has a 1 right here. Matthew?
Would you like multiply the two?
Yeah, so I have to multiply all of my exponents by 2. So I get 3 to the 1 times 2 times x to the power of 2 times 2. So can someone tell me what it becomes? Matthew?
3 to the power of 2
Yep.
times x to the power of 4.
Yep. And who can tell me what 3 to the power of 2 gives me? Maya. No, 9.
You would be thinking 2 to the power of 3.
3 to the power of 2 is 9. So, and what is the reasoning as to why 2x4 and 9x4 are like terms now? Kareem.
They have the same base.
Yeah, x to the power of 4, they have the same variable term. Yes, Claire?
What are the numbers above 3? Like bracket 62?
Where?
Like above the 3? No, or is it bracket 2? I'm
So-
sorry, I can't read the numbers.
Talking about this?
Like, I'm not underneath.
Oh, so that's 1 times 2 and 2 times 2.
Or like underneath. Like the 3 underneath. Yeah.
This one?
Oh, is
The
that a
little bracket.
yeah? What is it?
One bracket.
Yeah, it's 1 times 2, so it's 1 bracket 2.
Okay.
Sorry, I'm getting used to using multiplication as with brackets.
Wait, so another question. So this
Yeah.
is it like on a question?
Mhm.
Is a dot like
A dot. So multiplication is represented by this. Here, this is what you guys are going to be looking for.
But like, what if sometimes like I think it's like an issue with the paper?
You'll be able to see what an actual physical bold dot looks like. It's not good.
You need to look bigger.
So you'll either see like 2 to the power of 2 times 2 to the power of 3. And can you guys tell me what that gives me? 2 to the power of what? Matthew. Yeah, 2 to the power of 5. Because we add our exponents. You can also see multiplication like this. 2 to the power of 3 times 2 to the power of 4. Who can tell me what that gives me? Someone? Maya? 2 to the 7. And then the last way you'll see multiplication, even though I don't like writing it in this way, is let's say 2 to the power of 4 times 2 to the power of 5. And what would that give me? Matthew? 2 to the 9.
So you add in,
What, you're adding?
Yep, multiplication with the same base, you're adding.
Wait a
I didn't
minute.
ask you to evaluate, so you don't have to.
This is the product rule.
I think so. I don't know.
This is the
I
product
have to
rule.
see. So when if you get a negative exponent as your answer on the test, I mean not on the test, on the quiz, just leave it as a negative exponent. On the test, I'll ask you to switch it to a positive. Okay? And I know some of you remember how to do that. Okay? If you don't, be like Sean yesterday. He watched my video so kindly in class.
If you
He
feel like
supports
that,
me.
it's the zero exponent
Yes,
rule.
Daniel? Yeah.
I didn't feel like thinking about the zero exponent rule.
So, or if you have older siblings in the older grades, you can ask them. Some of them will still not know why you changed it to a positive exponent. So that may or may not be help. You should ask your brother, see if he knows. So yeah. So is everyone clear with the whole like term thing?
yeah.
Obviously.
Good? Okay.
We take a break now.
No.
No, this is only the first. We've only gone to the first two
So-
parts. No, I didn't see that.
Like we were saying before, remember to add and subtract terms, they must be like terms. Okay? That's step 1. They have to be like terms.
Not. Wait, what? You cannot add and subtract
Nope.
unlike
You
terms.
cannot add or subtract unlike terms. So if I have 2x squared plus 3x, do not write 5x squared or 5x3 because that's wrong. Do not write that. Okay? My variables are different. You cannot add the coefficients at all. So, and then what you do is you just add and subtract the coefficients in front of the variables. We leave the variable part the same, and that is that.
You can't change the variable part?
Nope. So I'm going to give you guys a couple of examples. So let's say I have 3x squared plus x plus 2x squared plus 3 minus 2. Guys, No, not right now. So what would the first thing we need to do be? What is the first thing we have to do? Okay, what are our like terms? Danica? Okay, and what's my second pair? Gian. Yeah. So constants, if you have numbers beside each other without variables, those are also like terms because you can subtract or add numbers from each other. So who can tell me what 3x squared plus 2x squared is? So there's a couple ways you can write it. You can either underline them, or once you've underlined them, if you're more visual and more organized and want to like not mess up, you can rewrite them. So you can have 3x squared plus 2x squared. That way they're beside each other. Plus x plus 3 minus 2. That way you're not messing up easily. So what's 3x squared plus 2x squared? Kareem? No.
Seriously.
Add the coefficients.
Oh. That's 5.
5 what?
5x.
Yep, good.
Now you got it.
Plus x, and then what's 3 minus 2? Austin? 1. So my answer is 5x squared plus x plus 1.
Oh, so when you add, you add coefficient.
Exactly.
When we subtract coefficient.
Exactly. There we go.
And then when you multiply.
There's no multiplying. No.
No, there's no.
I was about to say.
There's no multiplying.
Yeah, when you multiply, you use your exponent laws.
Product rule. Gotta remember the product rule.
No, not yet.
Okay.
Just let me do this example first. Okay. So my next example, I'm going to scroll up, is negative 4x cubed plus 2x squared plus 6x cubed plus 2x plus 3x plus 2. So identify my like terms first. What's my first pair of like terms? Austin.
4x3
Mm-hmm.
and 6x3.
Yep. So I'm going to write it as negative, don't forget the negative 4x cubed plus 6x cubed. Okay. My x squared does not have any like terms, so I'm going to leave it as is. What's my other pair of like terms? What is my other pair of like terms, Alice? Okay. And then the 2 is by itself. So what does this simplify into? So what is, now that we've collected our like terms, add and subtract them. Let's see. Gian?
Negative 4x3 plus 6
What would it be? Negative 4x cubed plus 6x cubed. What is it, Matthew?
The positive 2 to the power 6 x.
It's positive 2, so it's going to be 2x cubed, okay? All you're doing is you keep your variable part, you're just subtracting or adding the coefficients. So in this case, I had negative 4 plus 6, which is 2. So I got 2x cubed plus 2x squared. And what is 2x plus 3x? Alice? Plus 5x plus 2. You guys want me to do one more example?
We're good. We're good.
You're good?
I ain't a math professor.
I think
You can go now.
we pretty much understand.
Okay. I hope you guys understand.
We remember add, subtract, like terms.
Okay. So that's practically it for today. Like I said, it was a short lesson, so you can look